Welcome to today's tutorial. Today I want us to look at address resolution protocol spoofing. We are going to start with the theoretical part of it, and then we are going to dive into the practical part of it by the end of this tutorial. And we are going to finish by capturing traffic using the address resolution protocol spoofing. First of all, for us to understand the concept of address resolution protocol spoofing, we must first of all understand what address or the ARP does. Address resolution protocol is a protocol that maps IP addresses to MAC addresses. Think of an IP address like a phone number over the internet or your phone number to your device, and think of a MAC address like a house number, meaning that if, for example, I want to send information from me to you, I am going to need your house, or I'm going to need your phone number, and I'm also going to need your house address. So every device, the device you are using to watch this tutorial has an IP address because devices over the internet communicate using IP addresses. You can see in this case here, this is a network. We have user A, user B, user C, and user D here. User A has information for user B, and this information or this data which he has for user B, he doesn't want user C and user D to see that information. So what is he going to do? User A needs the telephone number of user B, which in this case is the device IP address, which is 10.1.1. That is why you see I want to connect to 10.1.1, but I need the MAC address. It's like saying I want to connect, I want to make a phone call to this person, but I don't know his house address. So what is he supposed to do? He needs a messenger. That is where the concept of ARP comes in, address resolution protocol. His device now, using his IP address, he is going to send an ARP request here saying that he needs to know who is the owner of this IP address in this network. He wants to know between user B, user C, and user D, who is the owner of this IP address, or in other words, the owner of this phone number. Now, user B is found here, and this is the same IP address that he has, or let's term it the same phone number. He needs to communicate with user A. Now, what happens is that the address resolution protocol is going to do a request, or it forwards a request to the switch. Think of this switch like a junction whereby, or a neighborhood whereby there are so many addresses, user B, user C, and user D. So the switch now is going to do what we call an address resolution protocol broadcast. It is going to shout in this neighborhood by saying between user B, user C, and user D, who is the owner of this IP address? Who is the owner of this phone number? And user B is expected to respond with this phone number, or to respond with this phone number by saying, I am here. This is my IP address, and this is my MAC address. This is my house address. Send that data to me, and now information now can now be sent to him, or it passes through the router. It's filtered, and then it goes to the legitimate user in a way that user C and user D cannot see this information. So this is like in the case whereby we have a marketing department here, we have an IT department, and data is meant only for the marketing department. We don't want the IT department to see that information which we are sending to the marketing department. So what do? We are going to need the address resolution protocol to do a broadcast in this network or in this neighborhood for that data to be sent to the marketing team alone. Now, where does ARP spoofing come in now? It is now a situation whereby an attacker now, who you can see here, wants to pretend to belong to the marketing team. He wants to pretend to be user B. So what is he going to do? He is going to manipulate in the network and spoof the IP address and fakes the IP address of user B, so much so that data that is meant for user B will now be sent to him here, will now be sent directly to him. So when user A now takes his information here and he sends an ARP request to the switch, when the switch broadcasts this ARP request to every other person in this network, the attacker now will rapidly come in the middle of the conversation and intercept it and say, and is going to respond back. He's going to give an ARP response saying that I am 10.1.1.1. Take note, this is the IP address of user B. Now the attacker is pretending to be user B, and then he rapidly does this and then present his own MAC address to user B or to user A. Remember that the MAC address is the house address which user A is seeking to send information to. So user A now, instead of sending that information to the switch for the switch to forward it to user B, that information now is going to be forwarded to the attacker here. And that is the concept of address resolution protocol. And this is how attackers do. And now he can be able to get information like your passwords. He can sniff every other information, snip data frames. He can manipulate your data and all of that. That is ARP spoofing. Now let us proceed to the practical part of it. Now we want to look at the practical part of this tutorial. The first thing we must note is that we have to look at this operating system here. What our target here is that we want that if this Windows operating system is communicating, we are going to be able to intercept traffic in our Kali Linux operating system and see whatever that conversation is that Windows operating system is doing. So what we want to do in this case is that we want to trick the Windows operating system to think that we are the switch. In this case, in our tutorial, we don't have a switch. We are communicating with the internet and we have a router. So the first thing we may want to consider doing is that we want to check the IP address of our Windows operating system. I'll do an IP config. I hit enter, and the Windows operating system's IP address, or what we call the telephone number of this operating system, is 192.168.40.135. And then we also have to take note of the default gateway. The default gateway here is going to act like our switch in this case. Remember that we are connected to the internet and we don't have a switch. In our tutorial, we have a router. So now that we know the default gateway, which is this, or which is the IP address that is given to the router, we are now going to come to our Windows operating system, and now, or we are going to come back to our Kali Linux, and what we want to do is that we want to trick Windows operating system using Kali Linux to think that Kali Linux is now the router, so that every information that Kali Linux or that Windows is going to be sending through this default gateway here, we are going to be able to intercept it in our Kali Linux operating system. But before we do this, we have to know that Kali Linux or Cyberhorn here, who is the attacker, is using an endpoint device like a PC or a workstation, meaning that it is not capable of forwarding traffic. So we have to give it powers to forward traffic by using sudo sys control w net.ipv4.ip.forward is equal to 1, and I hit enter. And you can now see that our Kali Linux or the attacker machine now is no longer an endpoint, but it is now having or now acting like a switch or like a router. So what is going to happen now is that I am going to now trick Windows operating system to think that I am the router. So the attacker now is going to do this. I am going to use this command sudo app sudo app spoof sudo app spoof -i for interface -eth0 if it were a wireless connection, we are going to have WLAN here dash T, and then we give it the IP address of the target who we want to spoof its IP address, and then we trick it to believe that we are now the default gateway. So Windows is going to believe that the default gateway, this IP address, now belongs to CyberHon, which in this case, it's going to believe that we are the router. So I'm going to hit enter like this, and then you can now see that here is the MAC address or the physical address of the router, and here is the MAC address, or in other words, the house address of Windows operating system. Meaning that this is user A in our case, or someone in the marketing department that wants to send information to someone in the same marketing department and don't want people to see it. So it needs a router. So now this router here has to respond back to Windows operating system. And for it to respond back to Windows operating system, it needs to present an ARP reply, meaning that Windows operating system is going to do an ARP request using her IP address as well as the MAC address, and then the router is going to respond with his own MAC address as with his own IP address as well as his own MAC address. By so doing, every data that is meant to be sent to Windows, or that every data that Windows want to send out to the internet, it must pass through the router. And remember that we have spoofed the IP address of the router and we are in this network, meaning that everything that passes through this router, we are going to see it because we are pretending that we are the legitimate owners of this router. I am going to come to this other side here, and what I'm going to do is that I am also going to now trick that same router, which I have tricked Windows to believe that I am the router. Me here as CyberHunt, I am going to trick the same router to now believe that I am Windows 7. So what I'm going to do, I'm going to do sudo ARP spoof. And now instead of putting 135, I'm going to come back here. Yeah, I think everything is okay. Everything is okay. What I'm doing here is now is that I want to spoof the IP address of the router to make the router now to believe that me as CyberHunt, I am the victim, that I am Windows operating system. So let me break it down again. In this side, I make Windows operating system to believe that I am the router. And here I make the router to believe that I am Windows, but I am in real life, I am CyberHunt. So if I hit enter, it asks for my password. I give it my password. I hit enter, and you're going to see that it is now running. So what is happening now is that Windows is thinking that I am the router. The router is thinking that I am Windows, but I am not the router. I am not the switch. I am CyberHunt. Meaning that any conversation between Windows and router, I am going to trap that conversation using tools like Ethercap or Wireshark, or I could use command line form of Wireshark, which is tcpdump, which is what I'm going to use in this case. So I am going to go to a new terminal by doing a Control Alt T. It takes me to a new terminal. I increase my characters, and then what I'm going to do is that I am going to run sudo tcpdump, and I am going to give it the interface -I for the interface. Our interface is ETH0 because we're using Ethernet. And then I am going to give it a -N, which is the number of ports, or the port number, which is, I'm giving it port 80. And then the next thing I'm going to do is that I'm going to give it, and I give it the host name. In our case here, the host here is a target whom we want to capture his traffic so far as he communicates in that network. And in this case, our target is Windows operating system. So I'm going to give you the IP address of Windows operating system, which is 192.168.40.135. And I hope our command is good. Yeah. And then I am going to give it enter. It asks for my password. I give it the password and then I hit enter. And now you can see that it says listening on ETH0 link type. We are done. The next thing we want to do now is we are going to come back to our Windows operating system here. Now, what is going to happen now is that what we have basically done is we are now in that system and we are now pretending to be the router, meaning that any conversation between the router and Windows operating system, we are going to intercept it. So let us launch something like Explorer and come back here and let's just say google.com and hit enter like this. And then what we're going to do is that we are going to come back to our Kali Linux and see what happens. And you can see the magic. You can see that we have captured traffic. Let me take it up. Let me take it up. If you look here, you see that this is the command which we just used. And then if you look at the first line here, it says that it gives us the date in which I am effectuating this sniffing or this app spoofing. It gives the IP address that is sending the information. It shows an ephemeral port number that this IP address is using to send that information. And then it shows the server that is being used over the internet. It shows the server IP address that is being used over the internet and the port number. Remember that we gave it a port number, port 80, which is an old protocol, an insecure protocol. And we are now able to trap every information that is being communicated over this network here. You can see that this is the scene flag that starts the TCP handshake, and we can see every other information. So this is how you can capture traffic over the internet using tcpdump, and this is how app spoofing is done, meaning that whatever thing that is done over the internet here by this Windows operating system, given the fact that the attacker now is pretending to be the router, the attacker is going to see every information that is sent here, or he is going to sniff every information that is sent over this router. So thank you for watching this tutorial up to now. This is how app spoofing is done. We are going to continue in our next tutorial by using Ethercap, using Wireshark to do more analysis. And please, disclaimer, this video is for learning purposes only. Do not do this if you don't have proper permission and you don't have proper documentation for this. My name is Banakengion. I am a certified ethical hacker.